Good morning, this is Dr. Turner for Integrated Math. Today we're going to be talking about 6.5, which is looking at scatter plots. Scatter plots are a way of looking at a set of data where potentially there is no relationship between the two variables. We're used to, in first semester, looking at linear functions primarily, where we can look at a set of data points and draw a straight line through them. However, that's not always the case, particularly in the real world where we're collecting data. The data may not follow a linear model or an exponential model or a quadratic model. And so when we record the data, we end up with a scatter plot, which, as the name might imply, the data is sort of just scattered all over the place. But there are certain things that we can comment on based on those data points, and that's our goal for today. So let's go ahead and get started here. If two variables are related, we call that correlation. Correlate, correlation. So if one affects the other, if two variables affect the other, then we can say that there's a relationship that exists between those two variables. That's what correlation is. Now, the correlation can change based on what variables we're comparing. So for instance, if I were to compare something, let's say like the amount of time spent watching TV versus the amount of homework that gets done, right? There's probably a relationship that exists there. The more you watch TV, the less time you're spending on your homework, and vice versa. However, if I compared something like your shoe size to the number of hours you played video games, there probably is not a relationship between those two things because one doesn't affect the other. So we can say that either correlation exists or no correlation exists. Now, of course, on a graph, if you're looking at points that are, if you're looking at a graph on an assignment, typically you're going to have labels here, right, for both your independent and dependent variables. But just to keep it simple, in your assignment, you're going to have a graph and you're going to have data points. And we'll zoom in here a little bit so you can see better. So if I have just a set of data points and they're just all over the place and there's no rhyme or reason to it, we would say that there's no correlation that exists here. Okay? So here, where we have points all over the place, we would say there's no correlation. Okay. Now, if there is some pattern to the data, then we say that there is a correlation. Now, depending on how those points line up, there is either a positive relationship that exists or a negative relationship that exists. So, just like with slope of a linear function, thinking back to our first assignment, if you have points and you could almost draw a straight line through them with a positive slope, let's say something like this, then we would say that that's an example of positive correlation. If, however, we could draw a negative line through those data points, like so, then we would say there is a negative correlation. Okay. Again, using the example of, let's say, the TV example, the more that your time on TV increases, more than likely the time you spend on your homework decreases, right? That would be an example of negative correlation. If you were comparing the amount of time you studied to your grades, that would potentially have a positive correlation. So the first part of this assignment is just being able to identify, is there a positive correlation between the variables that are shown in your graph? Is there a negative correlation, or is there no correlation? That's your first assignment. Okay. Then, from there, we want to assign some quantitative value to represent how strong the correlation is, if at all. And so what we call this a correlation coefficient. Now, there is a way to calculate the correlation coefficient, which you'll do if you take statistics your senior year or in college. But for now, we just kind of want to have a general understanding of what the correlation coefficient represents. So if the points were completely random, no rhyme or reason, we would say that there is a correlation coefficient of 0. And this is represented by a lowercase r. Computer wants me to capitalize it. But that would be a correlation coefficient of 0. No rhyme or reason. Okay. Now, if the relationship is positive, then we're going to have a positive correlation coefficient. If we have a negative relation, then we're going to have a negative correlation coefficient. But depending on how strongly those points are connected, I could have either a high or a low. Correlation coefficients will always be between -1 and +1. So if I was able to draw a straight line and it connected every single point on the graph, then that would represent a correlation coefficient of 1. Obviously, that's not going to be the case here for my example here, but kind of close. Almost a straight line would go through those. And then go in the opposite direction. If I could draw a straight line with a negative slope and it hit every single point, then that would represent a correlation coefficient of -1. So in addition to being able to identify is there a positive or negative relationship or none, the other thing that you're going to be asked to do in this assignment is estimate, if you will, what the correlation coefficient should be. So obviously if it's a straight shot, then that's not too bad. But if they're more spread out, let's say here, right, they're not as close as they are in the first example in the top left there, but there's some positive relationship. In general, it seems to be increasing as the other variable increases. So in that example, we would say that correlation coefficient is closer to 0.5, right? So there's a positive relationship that exists, but it's not super strong. So we would say that that has a correlation coefficient of positive 0.5. And going the other way, if there is some relationship that exists with a negative relationship, but maybe it's not as strong as the example in the top right there, again, say something like this, where in general we can see that as one is increasing, the other is decreasing, then we'd say that's closer to a correlation coefficient of -0.5. So you have two assignments or two tasks for this assignment. One is being able to identify positive, negative, or no correlation. And the other is given either 1, 0.5, 0, -0.5, or -1, being able to identify what's closest to the correlation coefficient of a given graph using these 5 examples. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.